Hello, in today's video I will be discussing angular momentum. I suggest that you go watch my previous video on problem number 24, as the problem I will be referring to later on in this video is a continuation of the first problem. So, getting right into angular momentum, essentially angular momentum describes how difficult it is to stop a rotating object or particle. The symbol for angular momentum is this, and the formula for it is R cross product P, where P is momentum and R is radius or distance. This can also be rewritten as R cross product mv, because we know that momentum is equal to mass times velocity. And this could also be rewritten as, right here, as mass times R cross product V. This can be done just because of simple substitution for this one and cross product rules for the other one. So now that we have our basic definition of angular momentum, I'm going to go ahead and apply this concept to an example. I'll be referring to problem number 25 on an AP multiple choice section exam. So first I'm going to go ahead and read the prompt. It says, two satellites of mass m1 and m2 orbit a planet of mass m in circular orbits. The satellites travel in opposite directions with speeds v1 and v2, as shown in the figure above. The orbital radii are r1 and r2, respectively. Assume that m is greater than m2, which is greater than m1. So I'm going to go ahead and draw this figure as well as the givens. So we have our planet here. We know that the planet has mass m. Then we've got our circular orbits. We've got two of those. Like that. And we say that this distance is r1. And then we've got r2 right there. And then it says the satellites travel in opposite directions with speeds v1 and v2. So we've got our first satellite here, which is m1, which moves with velocity 1 in the in opposite direction. So that means that m2 is going to move this way. v2, this is m2. Those represent the satellites, and then it's given that, or we have to assume that m is greater than m2, which is greater than m1. So, problem number 25 specifically asks, the magnitude of the angular momentum of the two satellite system is best represented by blank. So, we can go ahead and refer to this formula right here, since we know that we're looking for angular momentum. So I'm going to go ahead and write. Also, we want to find the absolute value, and we want to find the net angular momentum. So we're going to do that by finding L. Absolute value is equal to the absolute value of, well, essentially L1 minus L2, which is equal to M1, absolute value of M1 V1 R1 times minus M2 V2 R2. And we know that this is going to be negative because they're moving in opposite directions. So essentially this is moving in the negative direction. And then we see if this corresponds to any of the options. And it does. This is our final answer. And it is equal to that of option D. And thus we can conclude that the answer to problem number 25 is going to be D. Thank you.